Alright, hello everybody. Good evening. It is Andrew here from Central Illinois Weather, and today we're going to be talking about the potential for severe weather over the next few days. Let's go look at what the Storm Prediction Center has to say. So, for tomorrow, we have a large slight risk of severe weather from Dallas and Oklahoma into portions of Arkansas, extreme East Texas, north central Louisiana, western Mississippi, Tennessee, and into southern Kentucky in the boot heel of Missouri. We're talking about the risk for tornadoes, damaging wind gusts, and large hail. There could be a chance for a strong tornado or two in this kind of hatched area in here generally along the warm front. This is going to be your higher tornado zone. We could see a 10 hatched issued somewhere in here as well from the SBC if they get enough confidence. I don't think any other probability is going to go enhanced for tomorrow. The only probability that would be tornadoes. Now for Thursday, we are also watching the potential for severe weather. The more significant zones that I have kind of pulled out are kind of in here. This is where the more significant severe weather is probably going to occur, um, with strong tornadoes being a possibility and numerous reports of damaging wind gusts also being a possibility. I think a 30 knot wind gets issued tonight, and probably a 10 sig tornado risk gets issued, or at least a 10 non for this day. So let's dive into it. Let's first go into the upper level pattern on the HRRR and let's dissect that. So let's go into the upper level pattern here. And as you can see here, we have this initial shortwave trough that brought a couple severe thunderstorm warnings and rotating storms today across portions of Missouri and Kansas, and also brought this skinny squall line with rotation in Illinois and Missouri today with some nice mamatas on the backside of it. This trough is going to come out. We have a very amplified and potent trough that's going to swing in, and the most of the forcing is going to be generally and synoptically in Texas and Oklahoma, but since we still are in a La Nina, you have that subtropical jet pumping in moisture across portions of or Arkansas, Tennessee, Mississippi, and this is going to be a secondary zone for severe weather that could be quite significant tomorrow due to the subtropical jet doing numbers along the warm front. And I think that is the more significant zone right now, as moisture could be a little bit late arriving to the dry line, and we'll talk about that in a second. Um, Overnight, we can see that subtropical jet lift in and that trough really start to kick in and strengthen. As we get into Thursday, we can see very discrete storm vectors everywhere across the board. Anywhere from really southern Ohio down into Kentucky, Mississippi, Alabama. This area all has discrete storm vectors. And I think what you're going to get is you're going to get a line of embedded supercells to form along the cold front, Pacific cold front, and then you're going to get probably a couple discrete supercells ahead of the main area and confluence bands that could also produce a risk. And this could be a pretty potent risk. Up into northern Ohio, it looks like it's going to be more linear. Um, oh yeah, and you can see these little disturbances kind of moving through. Talking about the low-level jet, this is going to be, tomorrow's going to be one of those scenarios where the moisture arrives just in time for some of these areas as the warm front lifts north. A strong low-level jet is going to be the main reason why this is the case. Though this low-level jet does kind of weaken and meander throughout the day, it does strengthen heavily as you get towards 0Z, and you can see there's a pocket that's been pretty consistent. There's a low-pressure system that's forming in Oklahoma here. Pocket of 40-plus knot low-level jet is generally in here. Um, that's pretty much where the SBC risk is, and as you can see, it goes further north and strengthens to nearly 50 knots throughout the night. And then the next day in the morning, it's going to be 50 plus knots, but then that's going to lift up into Kentucky, Ohio, and looks like it's going to be 40 knots with another embedded wave down in Mississippi, which we'll talk about that. So let's first dive into kind of Wednesday. And let's go look at the composite reflectivity first. We'll just look at that to kind of give us a basis on what might occur. So as we can see here from the reflectivity spot, Storms are probably going to try to fire 22Z or so along the dry line. If we take a look at profiles where ahead of where the storms are firing with a box sounding in northern Texas, you can see they are quite capped. Did not mean to click on that. They are quite capped, and they also are a little bit lacking in wind shear, I'm not going to lie. That's because of this moisture not arriving. You are mixed out, but your moisture just isn't there. Once we get toward 23Z, though, especially further into northern Texas, you can see the moisture keeps getting better. And then once you get towards 0Z, I can't do that, but 0Z, this convection kind of dies off. I don't know if I would expect that to happen, especially further to the east. You see these box soundings keep getting better and better, but I'm not sure if you're going to get sustained convection. If you do, very large hail will be possible, though the SPC took that risk away. And as we can see here, along the warm front in northern Texas, there's going to be a risk for a isolated strong tornado if a storm can break the cap. Now, the other area to watch closely is this area of supercells developing along the nose of the subtropical jet plus warm front. Let's kind of stop it here at frame 25 and kind of dissect that. So you have embedded pockets of 3 Cape and vorticity really along the cold front there slash dry line. You have another embedded pocket along the warm front that's really just sitting anywhere in here. I would say anywhere above 50 joules per kilogram along the warm front would be sufficient. Looking at mixed layer Cape values, they're going to generally be 1,000 to 2,000 joules per kilogram along the warm front. Bulk shear vectors, one of the things we really look out for, they are looking pretty perpendicular to boundary motion for really everywhere. Looks like the subtropical jet's kind of pumping in that flow for that area. And if we look at the surface-based Cape and hodograph map here, we can see there's a lot of very enlarged hodographs across the region. I think Mississippi into Arkansas, though, looks like the most potent because this is where you actually have convection firing. If we take a look at reflectivity, and we take a sounding just south of it with the inflow feeding into it, you can see that's a pretty potent sounding, especially since you already have convection there. Here's another sounding in southern Arkansas, and let's dissect this one. You have a very streamlined low-level hodograph along with pretty solid upper-level wind support with cloud layer shear of 670 knots, which is solid. One of the negatives is this warm nose around 700 millibar, which will stunt storms from forming at first, and they will need multiple mergers to really bypass that, and they'll need to form anywhere between 22 to 01Z to have a shot. After that, that stable layer is going to keep getting worse. You have a pretty big EML with some good thermodynamics above that, so if it can tap into that and drill through this surface layer, your surface stable layer, you're gonna have a chance for tornadoes, including a couple strong. It's a conditional risk. Um, you can see here the HRRR fires off multiple supercells in this area. The most intense UH tracks appear to be in the Memphis area, and that's a little bit better in that area because you don't have that inversion at 700. You still have decent amounts of cape as well with not skinny cape, but not fat cape either. It's moderate instability. You have a very streamlined low-level hodograph as well, which will help out things. The only bad thing here is the stable layer causing low-level lapse rates to stay around 6 Celsius per kilometer. So again, you're going to need multiple storm mergers. You're going to need these storms are going to take a while. They're going to take their sweet time to really mature. But once you do get matured supercells, or if you do get matured supercells, the risk for strong tornadoes will be there along the warm front. Um, and you can see here the HRRR throughout the night keeps this risk of strong tornadoes along the warm front prevalent. And you can see multiple rounds of discrete supercells fire from Tennessee down into Mississippi along these confluence bands with the forcing of the subtropical jet. It's not really too surprising when since they form, given the fact that you do have some subtle confluence bands that kind of line up here, and also the warm front gives you some meager amount of forcing as well, not too high though. As we look into other models to see if they kind of agree with this, let's go give a quick look to the ARW model. Let's go to a forecast loop on this, and let's see if it kind of agrees. The ARW model is one of the models that does print supercells along the dry line. It also does do it along the warm front too. These are pretty intense supercells it outputs along the dry line with very favorable profiles for strong tornadoes. So if supercells do form along the dry line and have profiles like the ARW shows, you could have a strong tornado threat. And the ARW is multifaceted, but the thing is, along the dry line here, or along the warm front here, these supercells are elevated and not surface based. And then you can see here a line of embedded supercells fires off for the next day. Looking into the NSSL to give another idea on convective evolution for this setup, and we can see NSSL does not really fire much aside from elevated convection off the warm front, and morning convection could be a problem for the next day as well. So let's go over and talk about the next day now, which is Thursday, and let's go talk about kind of what Thursday could do across the southeast United States first. We'll give a brief look at that, and then we'll go up to the Tennessee River Valley, to Ohio River Valley region. So we can see here, could be an isolated strong storm along the warm front Wednesday in Mississippi. That would not surprise me. Into Alabama, there's a lot of 3 Cape. There is a small inversion at 700 millibars, though, which could limit things, and some decent 3 Cape in some spots. Wouldn't be surprised to see a tornado or 2 happen out of that. Then after this, of course, you have the warm front convection, and then bang, you have multiple kind of areas of supercells, one of which is down south from Louisiana to Mississippi, and another one is this embedded line of supercells. Um, let's go look at soundings here in Mississippi. This is going to be a messy mode in Mississippi. Soundings are a little bit contaminated, but they do support the risk for tornadoes. So that's something to kind of talk about as well. Um, looking at these supercells on that fire in northeast Louisiana there. I think a tornado or 2 are possible, maybe perhaps a strong tornado. I do think the greater overall tornado risk, though, is going to exist in northern Alabama into eastern Mississippi. Kind of this general zone is going to have a greater tornado risk. You have a bit more wind shear up there, and the storms are probably not going to be as messy as they are down south given all the precip. Looking at the HRRR, again, further north, the HRRR has a pretty good convective evolution as well. Looks pretty significant across portions of the Ohio Valley. You can see there's a lot of morning convection, which could stunt things if this doesn't lift north quickly enough, but it does, and we get breaks, and we see the stuff firing. Northern Kentucky, let's get a sounding for that. Not enough instability and moisture makes its way up there, but what about Central Kentucky? Central Kentucky, you don't have the wind shear, but you have everything else. And you get the secondary warm front there, kind of in south central Kentucky, and it looks pretty potent there. Looking into, I do think the greatest overall risk, though, is probably going to be from southern Tennessee throughout Mississippi, Tennessee, Alabama, kind of in here. The northern risk is quite conditional. It's there, but conditional. Other models, except the ARW, also have this risk out planning as well. Looking into kind of some of the other models here very quickly. The ARW is the model that doesn't really show as much stuff happening up north, but it has a pretty potent scenario for down south. As we can see here, as we just output the convection there, we can see it has multiple supercells kind of lasting out in the warm sector there, and nothing really happening up north. The NSSL, on the other hand, has the complete opposite with a bimodal, multifaceted kind of scenario like the HRRR. So I think that's probably more likely, but there is concerns with kind of the spatial extent. But I do think I do think rounds of discrete supercells are possible. So kind of keep an eye out. I think both days could get enhanced upgrades. Thursday more likely. I will see you guys in the next one though.